Welcome to Managing Log File Growth. So in order to manage log file growth, we have to understand why the log file grows. The most common reason is a long-running transaction or a long-running statement, some sort of large insert statement or large update statement or delete statement that's modifying a lot of rows and therefore causing the transaction log to grow simply because there's a lot of data being modified. Other reasons include full or bulk log recovery modes being set on the database without doing transaction log backups, or data modifications happening faster than log backups are occurring. There's lots of other potential reasons. Something I do see occasionally is an application creates a transaction, gets an error message somewhere along the line while doing that transaction, and doesn't roll the transaction back properly. At that point, the transaction stays open, and the user keeps doing work within this long transaction without knowing it because this is a bug in the application that's connecting to the database engine. Some people might say this is a bug within the database engine, but it's not. The database engine is simply doing what you've told it to. You, on the application side, did not handle the transaction rollback or commit correctly. Viewing how big your transaction log is fairly easy. You're going to use dbcc log info. This is just going to return a record set to you, and that record set is going to tell you all the virtual log files, or VLFs, within the transaction log. We're looking for VLFs that have a status of 2. That means that there's active transactions within those virtual log files, and that we can't overwrite that data for some reason. You can also use dbcc OpenTran to see what the oldest running transaction within the system is. Additionally, you can also query things like sys.dm execute requests and execute connections to see how transactions are flowing through the system and how commands are running. So let's go ahead and take a look at how to view the log usage and what the actual data is that's coming through the system. So I'm going to go ahead and open up a new query into the AdventureWorks 2012 database. I'm going to run the dbcc log info. Now, you do have to be either a database owner or a systems administrator to see this information. Now, you can see I've got quite a few virtual log files here. There's 32 on this system, and that's a perfectly fine number. We don't want the number of VLFs really growing to ridiculously high numbers. By ridiculously high, we mean in the thousands. We want the number of virtual log files as small as possible. The reason we want to keep the number of virtual log files as few as possible is because every time SQL Server closes this database and reopens it, it has to scan through every virtual log file. So if we've got thousands of virtual log files, it can take a long time for SQL Server to scan through those. Now, by a long time, you're probably looking at minutes. I have heard horror stories of people that have tens or hundreds of thousands of VLFs, and it taking hours for databases to come online, because SQL Server has to go through each one of those transaction log virtual log files, looking for transactions that need to be rolled back or rolled forward. Now, looking at this record set here, we obviously have a few fields. Recovery unit ID is just an internal column that's not exposed for anything useful today. The next one is the file ID. So this relates to the actual file that the transaction logs virtual log file is stored in. So database file 2 is going to be the default transaction log file that's first put on every database. If you have multiple files making up your transaction log, the VLFs here will identify which VLFs are in which file. The file size tells you how big the specific VLF is. The start offset tells you where in the transaction log file that virtual log file starts. The F sequence number, which will look different on your system than mine probably, simply tells you what the next virtual log file is and what the previous order is that they were used in and what the order they're going to be used in. As you can see here, I've got one virtual log file that has a status of 2. You're always going to have a virtual log file with a status of 2. That's where your current transactions are being written to. Because the database is open, that means there's a transaction that has happened because it had to mark that the database came online. So in this case, my F sequence number is 89, and that's where my status is 2 is. So that's my current one. So the next virtual log file that's going to be used is going to be the lowest F sequence number on the system. So in this case, if I scroll down, I'm pretty sure it's going to be 58. Yes. So the next transaction log virtual log file that's going to be used once this one becomes full is going to be 58. At that point, the F sequence number for that VLF will change from 58 to 90. When that happens, the parity column will change as well from 64 to 128. All that parity column is doing is something internal. It's not exposed to what it does, so we can't tell anybody what it does because we don't know. It's just internal to Microsoft. What we do know about that parity column is that it's going to change from 64 to 128 and then back to 64 every time that virtual log file goes active. The status column there, you can see you've got a status of 0 or a status of 2. There is no status of 1, so you're always going to see 0 or 2 there. Create LSN column is telling you what the LSN number was when this specific virtual log file was created. Now, as we need to manage these virtual log files, we need to grow them manually or we need to shrink them manually so that we can control the number of VLFs. Whenever we grow the transaction log, the number of VLFs increases. The smaller the increments are that the transaction log grows, the smaller the VLFs are going to be and the more of them we're going to have. So if you have a lot of VLFs, what you need to do is actually shrink the transaction log file and then grow the transaction log. So let's go ahead and do that. We're going to go ahead and shrink the transaction log, and we're going to release the unused pages. As you can see, we now have 2 virtual log files. We removed everything from the system. Now, this isn't going to be the best scenario to run our production application because we've only got the 2 virtual log files, and so we're going to be auto-growing instantly. So now we want to grow the transaction log to a larger size. We do this by looking at the Files page, changing the transaction log from 1 meg. Let's increase it to 8,000 megs. We typically recommend that manual growth of transaction log files is done 8,000 megs at a time. The reason for this is we want to get as close to 8 gigs as we can without being actually 8 gigs. There's a bug in some older versions of SQL Server where if you grow a transaction log file by 8 gigs exactly, it will actually only grow by a very small amount, just a couple of megs, on the first time you try to grow it by 8 gigs. This then creates some very small virtual log files within the transaction log. By growing 8,000 megs at a time, bypass this bug, and there's not that much downside. We're only creating our transaction log 192 megs smaller than the theoretical optimum size. So it's really not that big a deal to set it for 8,000 megs compared to 8192 or 8 gigs. So the reason this is taking so long to execute is because we're writing zeros to the hard drive. You have to remember that SQL Server, even with instant file initialization turned on, still has to zero out our transaction log as the file is expanded. That's why we don't want to set really large autogrowth settings for our transaction log, because if we do hit that autogrow, the end user that caused the autogrow has to wait for the autogrow to complete before their transaction can commit. We'll go ahead and continue the demonstration once this transaction log growth is completed.